Alright, let's get this show on the road, test number 3. Okay, so we have a data that's undergone an x-squared transformation, and they're all in the table below. We need to find a rule that connects them. And we know that our rule based on this value here, right, if our rule is y equals, it's mx squared plus c because it's an x squared transformation, this c would have to be 3. Right, and then all I need to do is pick an x squared value and a y value. So I'm going to do 1 and 5, sorry. So 5 equals m multiplied by 1 plus 3, which means 5 is equal to minus 3 from both sides, minus 3 and minus 3, m would be equal to 2. So we're looking for our y equals 2x squared plus 3, which is that one there. Okay. Next one. Okay. Same sort of question, it's just an inverse transformation. The rule connecting x and y is. So this time I'm not lucky enough to have a x equals 0 value, which is a little bit annoying, but that's okay. So there's probably a couple ways I can figure this out, but I would suggest, because it's multiple choice, the smartest way is just going to pick a value, because this is looking at x and y. Maybe have a look at substituting in these values and see what fits. Is probably what I'm thinking. So we have y is equal to 2 times whatever x is, which is 1 over 50 plus 96. That does not equal that, so it's not this first one. The second one, y is equal to 200 over x, which is 1 over 100, so that becomes, what, 2096, so it's probably not that one either. Y is equal to 3 divided by 1 over 100. I know that if you do this on the CAS it works better, but if you do it by hand, if you divide by a fraction, you just multiply this one to the top. It becomes 300 over 1. So 300 minus 4 is 296, so that works for the first one. Let's see if it works for the next one. 4 over x. Oh, sorry, 3 over x. So 3 over that would give me 150 minus 4, so it works for the second one. I'm going to do that again. 3 over 10 is the same as 30. So 3 over 1 over 10 is the same as 30. Minus 4 is 26. And the same goes for here, I would assume. 3 divided by 1/5 is the same as 15. Minus 4 gives you 11. So that C ticks everything off. So that's would be the correct answer. Probably a better way of figuring that out, but that's the way that I make it work. Alright, so this is a log 10 transformation. The original data x and the transformation data are given as well as the corresponding y values. What's the rule connecting x and y? Alright. This time we have log 10 of x actually in the question, which helps. So it's saying 1.2 times whatever log 10 of x is plus 0.3. Okay. So we can sort of do what we did before, although we don't have a 0 value, which is a bit annoying. That's okay. I can do what I did before, and that would be okay, I think. Yeah, I think it's probably the best thing to do. I'll just see what fits. Okay, so let's start with 1.2 times log 10 of x. 1.2 times 1.4 is what it's not much. Don't think that will work. Let me just bring up that calculator and have a look. (1.2) times 1.4 plus 0.3 is 198, so that one doesn't work. So it's not that first one. Log 10 of x plus 4. That would give you 5.4, so that one's wrong as well. 2 times log 10 of x plus 3. So 2 times log 10 of x would give you 2.8, plus 3 would give you 5.8, so that one's wrong as well. 3 log 10 of x plus 1 would give you, what's 3 times 1.4? Be 2.8, 4.2, plus 1's 5.2. So it has to be this one. 4 times that, 4 times 1.4 is 5.6 minus 1, so that works. So it's got to be E. There's no point even checking the rest because it's the only one that's possible. The following data is to be linearized using log 10 of x. Rule connecting x and y is. Alright. So if we were to do a log 10 of x, so remember that's just 10 to the power of what? So it's 10 to the power of 0, 10 to the power of 1, to the power of 2, to the power of 3. Okay. So in this case, what are we thinking? Well, whatever it is, it's going to have to be something like y equals m. So this is log 10 of x plus c. I think the plus c has to be 12. So it'll be y equals m log 10 of x plus 12 is what I'm thinking. And that's only because this is a 0 value here, meaning that that's the y-intercept. Okay, so we got that. Now we're just going to find the m, and I can sub 2 points in here. So let's do this one. So we have 18 is equal to m multiplied by the corresponding log 10 of x is just 1 plus 12 minus 12 from both sides gives me m equals 6, which means it's y equals 6 log 10 of x plus 12, which is that one there. Okay. Alright, pressure and volume of a fixed mass of gas when the temperature is constant is recorded on the table. The data is to be linearized as a 1 on V transformation. Okay. I can do that. 1 on V. 1 divided by 1 is 1. That's 1/5, 1/10, 1/25, 1/50th, and 1 over 100. Okay. So the rules in terms of P and V is P is equal to, so it's is this a direct? Doesn't say. Okay, doesn't say. That's all right. We'll have y equals instead of mx, I think it'd be m over v plus c. If I'm doing that right. Hopefully I've done that right. Okay. So again, I would like to normally try and find my c, but there isn't one this time, which is a bit annoying. But that's okay. What can we do instead? I might just have to go back to the other way and see what fits. I'll have to do that. Alright, so let's just see what fits. So P, pressure, equals to 100 divided by V. That works. Does that work for this one? 100 divided by 5, yeah. 100 divided by 10, yes. 100 divided by 25, yeah, okay. So it could be that first one. I think it's that first one. I'll just double check. P is equal to V divided by 100, so that would be 1 over 100, so that's wrong. 20 over V plus 80, 20 over 1 plus 80 is fine. 20 over 5 is 4 plus 80 is 84, so that's wrong. 100V, that would be 500, so that's wrong. And 10V, that would be 50, so that's wrong. So yeah, it is the first one. Alright, that was nice and easy. Alright, time taken in hours T and the number of workers N to construct a brick wall is recorded. The data is to be linearized using a 1 on N. Okay, just helps me visualize it if I have that there. The rule, alright, so we don't have any zeros, so I'm going to have to do sort of trial and error to get the rule. And the rule in this case, we have a half and, oh sorry, we have 2 and 26, because we're looking at N and T, because we're looking at it here. So T, 26 is equal to 13 times N, that works. T, 17 equals 13 times N, well that one's wrong. So it's not the first one. So T equals 13 divided by N, that would give you 6.5, so that's wrong. T is equal to 4 divided by N plus 12, so that would give you 14, so that one's wrong as well. T is equal to 10 divided by N, so that would be 5, plus 10.6 gives you 15.6. Okay, T equals to 36 divided by 2, which is 18, plus 8 is 26. 36 divided by 4, which is 9, plus 8 is 17. Divided by 6, plus 8 is 14, yeah, and so on. Anyway, you get the idea, that's the right one. Given the table of values for the rule, y is equal to log 10x plus c, okay. So log of x, I don't know these ones, I have to do these. Log of 10. Log of 3 is 0.5. .5. 2.5. I'm assuming this is 3.5. Yeah. Alright, the values of k and c respectively are, okay, so the rule is y equals k log 10 of x plus c. Alright, well, I think what I'm going to do is I'm just going to have to test these out. So for this first one, it's y equals just log 10 of x plus 0.34. So that one's wrong straight away. So it's not that. So cross. Now y equals 7 log 10 of x minus 20.24. Okay, log 10 of x is about 0.5 times 7 gives you 3.5. So yeah, that's not yeah, it's not good. Okay. Let's try the next one. Y equals 7 log 10 of x minus 19.66. And again, that's 3.5 minus 19 is not that. So for that one, y equals 7 log 10 of x minus 2. 7 times that is 3.5 minus 2. It could be right because it's not actually 0.5, is it? It's 3. It's 4.77. So I've probably been doing that wrong. So that times 7 gives me 3.339. And if I were to then minus 2, that would give me 1.34. Okay, so that appears to be the correct one. I'll quickly do the other one just in case. Y equals 7 log 10 of x plus 10.34 would give me like 13 or something, so it's not that one. Yeah, so it's got to be D. Hopefully that was in shot for most of it. I'm almost there, last page. Given the table of values kx squared plus c, you've got to find the values of k and c. Mm, 36. Okay. Well, there's a couple of ways we could go about doing this. We could do the same thing that I did on the last question, or I can just work these values back to 0 if there's some sort of related pattern here. It's, what's that? Minus 33 minus 27 minus 21. So if there's like a second tier pattern in there, we might have something. Yeah, which is minusing 6 each time. So there is a second tier pattern in there. Which means in theory, this should be 2 and minus 15. Like that. Which should also be 1 and, if I'm minusing 15 minus 6, that's what, 9? So it's a negative 4. And then, I'm not sure if you're following along with that idea or not. But the idea is because this pattern is decreasing by the same amount each time, I should be able to predict the rest of it. So it would be minus 3, so that should be negative 7. Should be the y-intercept, which means that A is the correct answer. So anyway, we'll try A and see if it works. So in theory, that number pattern works because when you're dealing with a squared problem, you're not just looking at the distance between numbers like a linear one. You can actually look at a second tier to see if there's a pattern, which can help you. But anyway, let's check. So we have the values of k and c are... Oh no, I've done that wrong. Shoot. Minus 21, minus 15, minus 9, minus 3. Oh, it's because they got them the reverse. That's dodgy. Yeah, it is A. But anyway. Alright. So y is equal to kx squared plus c. Let's replace the c and the k. And see if that fits for any of these. So 3 times 36 is what? 90, 108 minus 7, so that works for that. 75 minus 7 works for that. What's that? 32, 48 minus 7, 27 minus 7, so you can tell it works for all of them. It's just that they've swapped this C and K around, they're trying to be dodgy. But if you did want to do my second tier pattern back, you'll find that the y-intercept is 7. You would then do y equals kx minus 7. Pick a plot point to substitute in. So k3 minus 7 plus 7 to both sides equals 3k. Divide both sides by 3. Oh, I've stuffed that up as well. My goodness. How have I done that? Oh, because I'm supposed to be using x squared, that's why. So it's 20 and 9. 9k, there we go. Okay, so it's 9k, which gives you 3. So then you can figure it out from there. Sorry if that was a little confusing. Alright. During a mice plague, the population of mice increases as shown in the table where t is the time in days. Okay. Perform a squared transformation to the variable t and find a rule which allows it. Okay, cool. We can do that. Alright, squaring. So 125, 100, 400. Alright. So now we're finding a rule. My advice might be to try and find this pattern again in P. What I call a secondary pattern. Just helps you through it. I'm trying to think of another way to do it. I think that's going to be the best way to do it. So, other than like plotting it maybe, or I suppose you could put it in your CAS. Anyway, all right. Let's do a tertiary pattern. So I'm looking at P, not T squared. So distance between them is 1500. The distance between them is 100 and something. The distance between them is 375. The distance between them is 120. So a bit of a pattern there. Not that easy to tell. Because it's not going down by regular numbers. That's why that's not going to work. Alright, what else can I do? Moving a mouse plate P, the mice hands in the table showing where T is the number of days. Form a squared transformation of the variable T time and find a rule. Okay, let's try solving for we try solving for K. Let me just bring up my notes on this one. Because off the top of my head, I'm not too sure. Alright. Oh yeah, I can just use rise over run. Why didn't I do that all the other times? Alright. We can just plot. We can use 2 points to find the gradient. So using rise over run. So the old, or y2 minus y1 over x2 minus x1. I can do that and use 2 different points. So let's do that. Let's use 135 and 15 divided by 25 and 1, which equals 120 over 24, which is 5 if I'm correct. So that gives me y equals 5x squared plus c. Now I can find my plus c just by subbing in a random point. So I'll do this one. Why not? 510 is equal to 5 times my x squared is 100 plus c. This ends up being a nice easy one. 500 plus c, which means c is equal to 10. So y equals 5x plus 10 should work for, or 5x squared. And also, because it's in P and V, P and T rather. So P is equal to 5 times time squared plus 10. That'll give you the full marks. Alright, yeah, sorry that took me so long, and I had a bit of a brain fade at the end, but I hope you find this valuable. Thanks, bye.